Hey dosers, what's up and welcome back to another video. Today we're going to be focusing on the continuity of functions. So let's get right into it. So for a function to be continuous, let's say you have f of a and you limit your f of x function at x going to a, x approaching a. What does it mean to be continuous? Well, a simple definition is that if you have a point and you want to observe whether it is continuous or not, just imagine if it is any between these things. So if these are one of your points, that means that your function is continuous. Okay? But in the harder definition, f is continuous at x equals a. So you have your point x equals to a. And if you want to find out if this is continuous and you don't have a graph, find out if a. So plug a into your f of x function and limit as x approaches a of f of x exists, and both of these are equal. So for x equals to a to be continuous, f of a has to be equal to limit as x a of f of x. These two have to exist. That is the requirement for x equals a to be continuous. Okay. If f of x is not continuous at x equals to a, we say that f is discontinuous at x equals to a, or has a discontinuity x equals to a. Okay? So graphically, we have seen that isolated points of discontinuity are indicated on the graph of y equals f of x. So these are discontinuities over here. This, and this, and this. So this right here, let me just zoom in a little bit. This right here are the three types of discontinuities that you can have. So you have a hole, this hole, right? Blatantly obvious. That this is called a jump. That means that this is still f of x. This is f of x, and this is also f of x. But there's a gap in between them. That is called a jump. Yes? And this circle that is given here, it is a hole, but this signifies that in the f of x function, whatever this point may be, let's say this point is 1. If this point is x is equal to 1, it is not part of f of x. So f of x is defined, but f defined as x any element of R and an element of real numbers, but x cannot equal to 1. That is what this whole means. While this one, let's say this is 0.9. Yeah? If this is 0.9, if this point is 0.9, x is equal to 0.9, this means that x is an element of R including 0.9. So that means that x also is equal to 0.9 and it exists for x. This is because this hole over here, this is filled in. This means if this is the point that's given, that means that x, value of x is given for this point, it is part of f of x. However, this is not. That means whatever point this is, it is not part of f of x. I hope that makes sense. Okay, let's get back into what we were focusing on. So we talked about jump now. Now, what if you have, do you guys remember what this? Yes, this is an asymptote. This is a vertical asymptote. Okay? And that is what we call a discontinuity. Okay? Hopefully that makes sense. Now, if f has a hole at x equals to a, then limit as x approaches a, f of x exists. The hole is a removable discontinuity which can be removed by defining a new function of f, but which takes the value of lim at x approaches f of x when x is equal to a. Basically, what this means is that don't focus on any of this. You don't need to know much about this. They're not going to ask you what a removable and essential discontinuity is. Please forget all of this, okay? If you want to understand the concept really well, you have to ignore some things in life. That's lesson number 1 that I've taught you guys. Okay? Now let's do a question that'll help you understand it better. So discuss the continuity of the functions. If there is a removable discontinuity, describe how it could be removed. So basically just asking you, is there a discontinuity and discontinuity be removed? Ignore this. In a question in your Maths AHL paper 1, paper 2, or paper 3, they're never going to mention removable or essential. I guarantee you, I've done, I don't know, really past papers, they've never mentioned this. Only in the textbooks or any random questions that you find online, they might mention this, or if you ask ChatGPT to make questions for you, they'll mention this, but never after that. Always ask discontinuity or continuity. So let's see this function. We have f of x, right? So what helps over here is to also draw a graph, right? But we can clearly see from this function that at x is equal to 5, right? The value of f of x becomes 1 over 5, which is 1 over 0. So that means x equals 5 does not exist. Does not exist whatsoever. We can illustrate this on a graph, right? When we illustrate this on a graph, it looks something like this. So the graph goes like this, and then we have our asymptote here. Obviously, I'm not drawing it to exact accuracy, but this is somewhere around what it looks like. And this would be x is equal to 5. So we see here, do you remember what this is called? This is called a break. So we have a break here. So this is discontinuous, and this is a discontinuous graph. Yes? So that means when we write this function, the continuity of f of x as f of x is continuous. How do you spell continuous? Continuous. Yes. F of x is continuous for all x element of real number, right? Except, you put a comma here, cannot equal to 5. That's how you illustrate the continuity of f of x. And now let's look at the mark scheme. Yeah, perfect. Okay. Essential discontinuity at x equals to 5. Essential and non-essential, no. Essential and removable discontinuity are the two types of continuity that you have. Just remember that an asymptote will be an essential discontinuity, right? But a removable discontinuity would be your hole and jump. Okay? That's all you need to remember. I hope that makes sense. Now you have homework over here. Now, just remember what I just told you, right? About the removable. I feel bad for not teaching it to you, so I'm going to teach it to you real quick. So removable equals hole, comma, jump, while essential equals to asymptote bracket break. Okay? All right? Perfect. Now, you've learned everything that you need to know about continuity of functions. Now, the mark scheme is on the other slide. The Canva slides will be provided in the description below, so please do go ahead and check them out. And please do the homework. They really, really help. Okay, that's all for today. Thank you so much for watching today's video. I hope you've enjoyed it and hope you've understood something today. If you liked this video, please like, share, subscribe. Send this to any mates that might be struggling with math. Yeah, because I realize it can be hard. So thank you so much. Take care. This is SK signing off.